Welcome to Science Snippets, Fun Facts, and Trivia. Today, we bring you Do Multiverses Really Exist? Exploring the possibility of parallel worlds. The multiverse theory is a concept that has fascinated scientists, philosophers, and even science fiction writers for decades. But what exactly is it? In simple terms, the multiverse theory suggests that our universe might not be the only one. There could be countless other universes, each existing in its own separate dimension or reality. These parallel universes could be vastly different from ours, or they might be eerily similar. Each universe would follow its own set of physical laws and constants. The idea of multiple universes isn't new. In fact, it has roots in ancient philosophy. Greek thinkers like Anaximander speculated about the existence of other worlds beyond our own. However, it wasn't until the 20th century, with the advent of quantum mechanics and modern cosmology, that the idea of a multiverse became a serious scientific hypothesis. So, how does quantum mechanics fit into all this? Quantum mechanics is the branch of physics that deals with the very small, subatomic particles that behave in strange and unpredictable ways. One of the key principles of quantum mechanics is the idea of superposition. This means that particles can exist in multiple states simultaneously, only choosing one state when they are observed. Some scientists have extended this concept further, proposing that each time a quantum decision is made, such as when a particle chooses a state, an entirely new universe is created where the alternative outcome occurs. In this framework, every possibility you can imagine might exist in a different universe. There could be a universe where dinosaurs never went extinct, or one where humans evolved wings, and countless other variations. While this idea is intriguing, proving it is an immense challenge. Next, we will explore the different types of multiverses proposed by scientists, and how each one tries to explain the possibility of parallel worlds. Scientists have proposed several types of multiverse theories, each offering a unique perspective on parallel worlds. Let's explore some of the most intriguing ones. First, there is the bubble universe theory. According to this idea, our universe is just one bubble in a vast cosmic foam. Each bubble represents a different universe, with its own distinct physical laws. These bubbles may never interact with each other, but together they form a massive multiverse. Next is the quantum multiverse, which is closely tied to quantum mechanics. As mentioned earlier, every quantum decision, when a particle chooses a state, could create a new universe. This means that an infinite number of parallel universes could be branching out every second, with each universe following a different path based on these quantum events. Then, there is the braneworld multiverse. In this theory, our universe exists on a three-dimensional brain, which is like a membrane floating in a higher dimensional space. Other brains could exist parallel to ours, and collisions between these brains might even explain cosmic events such as the Big Bang. Each of these theories offers a different vision of how multiverses might work. However, they all face a common challenge: the lack of direct evidence. While the science behind these ideas is fascinating, proving them is incredibly difficult. Now, let's dive into what evidence, if any, might support these multiverse ideas, and why some scientists remain skeptical. Is there any evidence that multiverses actually exist? Let's look at both the evidence supporting the idea and the reasons why some scientists remain skeptical. On the side of supporting evidence, we have observations from cosmology. Some researchers believe that the cosmic microwave background, which is the faint radiation left over from the Big Bang, contains subtle patterns that might hint at interactions between our universe and others. These patterns could potentially be the result of bubble collisions, as suggested by the bubble universe theory. Another potential clue comes from the quantum realm, the strange behavior of particles in quantum mechanics, especially phenomena like superposition and entanglement, has led some to speculate that these behaviors could be influenced by parallel universes. However, this idea is still highly debated and far from confirmed. Despite these intriguing possibilities, there is no concrete or direct evidence for the existence of multiverses. This brings us to one of the main arguments against the theory testability. In science, a theory must be testable to be considered valid. The problem with multiverse theories is that they are extremely difficult, if not impossible, to test with our current technology. If we cannot interact with these other universes, how can we ever prove they exist? This lack of evidence has led some scientists to view the multiverse hypothesis as more of a philosophical idea than a scientific one. While the concept is exciting and captures the imagination, it remains speculative without hard data to back it up. Now that we've covered the evidence, let's consider what the implications would be if multiverses were real. How would it change our understanding of reality? If multiverses do exist, the implications would be nothing short of revolutionary. It would fundamentally change how we understand our place in the cosmos. So, what would it mean if parallel universes were real? First, it would redefine our understanding of physics. Right now, we think of the laws of physics as universal, meaning they apply everywhere in our universe. However, if multiverses exist, each universe could have its own unique set of physical laws. Gravity might be weaker in one universe, or time could flow differently in another. This would challenge the very foundations of our knowledge about how the universe works. Second, there are deep philosophical and ethical questions that arise. For instance, if every possible version of reality exists somewhere, what does that mean for our choices? Are we just one version of ourselves among countless others, living out different possibilities? The idea of free will becomes more complex when you consider that, in some other universe, a different version of you might be making completely opposite decisions. Moreover, the multiverse could reshape how we think about life itself. If there are infinite universes, then there is a high probability that life, possibly even intelligent life, exists in some of them. This raises questions about how we might approach the idea of life forms in other universes that we might never be able to meet or communicate with. Finally, discovering the multiverse would profoundly alter how we view reality. The idea that our universe is just one of countless others would shift our perspective from a singular existence to one that is part of an incomprehensibly vast and diverse cosmos. It would challenge our understanding of existence, time, and space in ways that we can barely imagine. Next, we'll explore the future of multiverse research and what scientists are doing today to try and prove or disprove this fascinating theory. As of now, the multiverse remains a captivating yet unproven that is. However, scientists are actively exploring ways to test the theory and potentially gather evidence. So, what does the future hold for multiverse research? First, there are several ongoing projects in cosmology and particle physics. Researchers are using advanced telescopes and instruments to study the cosmic microwave background, which is the faint radiation left over from the Big Bang. Some scientists hope that by examining this radiation in even greater detail, we might detect signs of bubble collisions or other anomalies that could suggest the existence of other universes. Another exciting area of research is quantum computing. As quantum computers become more powerful, they could help us simulate conditions where parallel universes might emerge, even if we can't directly observe these universes. Quantum computers might offer insights into how particles behave in different scenarios at the quantum level. While we're still in the early stages, breakthroughs in quantum technology could bring us closer to understanding the multiverse. However, there are also significant challenges. One of the biggest obstacles to proving the multiverse is that these other universes may be fundamentally unreachable. If we cannot observe or interact with them in any meaningful way, how can we ever confirm their existence? Some scientists argue that without testable predictions, the multiverse might always remain a philosophical idea rather than a scientific theory. Despite these challenges, many researchers remain optimistic. They believe that as technology advances and our understanding of the universe deepens, we may one day find indirect evidence of the multiverse, whether it's through new discoveries in cosmology or breakthroughs in quantum physics. The search for parallel worlds is far from over. So while we don't have proof yet, the multiverse remains one of the most intriguing ideas in modern science. Who knows what discoveries await us in the future? If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.